Okay, we're going to do a little bit of a review of sampling distributions. Hopefully this helps a little bit kind of crystallize what we talked about. So again, what a sampling distribution really is, we don't know the real answer to a problem. We don't know what the true proportion of people who believe something. We don't know what the true, income is in a certain area. So what we end up doing is we end up going and collecting information. So what happens is we go out and we talk to a group of people. And what we do is we get what's called a p hat for proportions. It's our number of successes out of the number of people I talk to. So let's say, for example, I went out and I talked to 100 people and 72 people agreed with some topic, whatever the newest name of a football team is, for example. So all of a sudden I find out that 72% of this sample approved that. So what happens is I all of a sudden have this p hat, and what happens is I keep going out and I keep talking to groups of 100 people over and over and over again. What happens is these p hats start stacking up. If I follow a certain set of protocols and rules, what happens is this thing starts to kind of form a pattern, and the pattern actually helps me get an answer. So in this case, I've talked to 9 different people, and I noticed that all these p hats center on at 72. So what that's telling me is that maybe perhaps I could suggest that the true proportion is 0.72. So that's the idea of what a sampling distribution kind of is in like the grand scheme. So then let's kind of go over our ideas of what a sampling distribution are. So we're going to start with one sample proportion. And in that case, the parameter is p, and that's the true proportion. That is the real answer. That is if we talked to everybody and got everybody's opinion and figured out whether they support something or not. So this p is equal to like a big X over a big N. It is everybody's success out of all the people I talk to. So if I talk to 100 million people and I found out that 72 million people believe something, that's 72 million out of 100 million, my p would be 0.72. But again, we never really know that. So what we're going to do is we're going to use a p hat, which is a sample proportion. So now here's the deal. As we work our way through the problems, what's going to happen is we're going to follow a certain set of processes. In this case, if this thing is stated as random, if our problem is stated that we're collecting our samples randomly, if stated random, I can then figure out that the mean of all of those p hats is going to equal the true proportion. So again, that visualization, averaging all of these 9 p hats is going to give me a p that is the real answer. Standard deviation. The check we do for standard deviations, we're checking for independence. And there are 2 ways to check for independence right now. Let's just focus on the following. The independence check is we're going to go ahead and we're going to check and confirm that we didn't take too large a sample size. The check is this: 10n less than or equal to big N. So what I'm saying is I'm going to take my sample size. So in this case, let's say I talk to 100 people, 10 times 100 is 1,000. I'm going to confirm that that population I'm pulling from exceeds 1,000. I don't want it, it's not independent if it breaks that rule. But if it abides by that rule, I am now allowed to use this formula. And I'm going to show you where both of these formulas are on the formula sheet, so that I can plug in those numbers at p and that n into the formula. And again, on the back side of your formula sheet, there's your mean and there's your standard deviation of the sampling distribution of proportions, one sample. We'll come back to this in a moment. This is 2 samples. And in terms of what condition must I meet for that, it's kind of what I said there. I'm going to do 10n less than or equal to big N. So what I'm going to do is I'm going to check and confirm that my sample is not larger than 1/10 of my population. Okay. Now the next thing what we want to do is when is the sampling distribution approximately normal? And in this case, the way I check that is I need to have 10 or more successes. And I need to have 10 or more failures. What I mean is I have to take a sufficiently large. So the previous one said, I can't take too big a sample size. This one is saying I can't take too small a sample size. There's like a sweet spot. And the way I figure that out is I take the number of people I'm talking to in the sample, and I multiply it times that P, the claimed proportion. And if that number exceeds 10, that's 10 or more successes. If this N-1 minus P, this is my failures. If it exceeds both of those, I can now go ahead and say that the distribution is approximately normal. We're not going to worry so much about the z-score formula. We're not going to worry about that. I can show you what it is. But really what that tells me is that if I do these checks, I can determine that a distribution is normal, approximately normal, that it's centered at the true proportion, whatever the claimed proportion is in the problem, and it has a calculable standard deviation, P1 minus P over N. So now that I have this, I can draw pictures and I can answer questions about anything that may come up when it comes to one sample proportion. So that's a one sample proportion. I'm going to go ahead and walk through what a two sample proportion is and see that it's similar. It's just doing everything twice. So again, in terms of my parameter here is going to be P1 minus P2. I'm going to tell you it's going to always be a difference, because we're trying to figure out if they're different. So P1 minus P2, really what a lot of times we're looking for is we're looking for 0, because 0 would imply no difference. So if I had two proportions and when I subtracted them, I got a 0, that would say that there's no difference between the two proportions. So like, let's say I was surveying men and women and asking them a question. If the proportion of men who believe something and the proportion of women who believe something, if their difference is 0, what that says is there's really no difference between what men and women feel on a certain topic. Okay. So the statistic we use is we're going to get a p hat 1, a sample from our first group. Say, for example, men, we're going to get a p hat 2, which would be perhaps from women. And we'll look at the difference there. In terms of the checks, I want to check random on both. So what I just did, check random on both. And if that is the case, I'm allowed to say this, that the difference in means is equal to the mean difference is equal to the difference in means. I can do P1 minus P2. Independence, I'm going to show you the formula. The formula is going to be this. And again, these are on your formula sheet, so you don't need to memorize them. You just need to know where to find them. So this will be P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2. And again, right here on the formula sheet, this is a two sample, two populations of difference. There's your mean, there's your standard deviation. It's the same check. You're going to check the 10n less than or equal to big N for both. You need to make sure that both of them aren't too large a sample size. For the shape, you're going to check the successes and failures for both. So you're going to do N1 P1 greater than or equal to 10, N2 P2 greater than or equal to 10, N1 1 minus P1 greater than or equal to 10, and 2 1 minus P2 greater than or equal to 10. You want to make sure that both samples have enough successes and failures, and if both of those are met, the difference is also going to be approximately normal. And again, the reason that I want to do this is because I want to be able to figure out a normal distribution centered at a calculable mean and a calculable standard deviation. N1 plus P2, 1 minus P2 over N2. So the whole idea on proportions is I'm looking for random, I'm looking for independent, I'm looking for normal. Now the normal check is, that 10 or more successes. The independent check is the 10n, and the random check is, does it state random? So that's what it is for proportions. I'm going to do a second video that'll also talk about means, and I'll kind of talk about what's similar and what's different in those.